Hello, and welcome to Structures 2. I'm your instructor, Chris Barlow, but you can just call me Chris. The purpose of this first video will be to introduce you to the course as well as to myself as your instructor. The following videos will cover, first, a review of topics from Structures 1, specifically to do with some math like trigonometry and unit conversions, and it will include an ARE example. And I think it's important that we start with this math review because this is a physics-based course, a structural engineering course, and so there is going to be some math and physics involved. That being said, it's not going to be a very intensive mathematical course. The really hard math we save for the structural engineers. However, for you to have a firm grasp of the core concepts of structural engineering, which is important both for your career and for passing the ARE exam, we are going to need to review some basic fundamental mathematic principles. After that, we will cover the roles and responsibilities of structural engineers versus architects, because I think it's really important for you to know the distinction between these two disciplines. You likely are already fairly familiar with the roles and responsibilities of an architect. However, you may not necessarily know where exactly structural engineers come into play. And so I will be providing some guidance from the perspective of a structural engineer. And lastly, for our main topic, we will start discussing types of loads. And specifically, this week we will be covering gravity loads. So, with that broader agenda in mind, let's jump into introductions. As I said, my name is Chris, and I am a structural engineer in training at Canon Design, where I've been working for about 2 years now. I received both my bachelor's and master's degrees in architectural engineering at Penn State, and you may be surprised to learn that Penn State is actually the #1 school in the country for architectural engineering. So as you progress through your career, it's pretty likely that you will run into a Penn State alum in the architectural industry, if you haven't already. So those are the basics of who I am and what I do and my credentials, I guess. But that doesn't really tell you much about who I am as a person and what you can expect from me as an instructor. So, on a more personal note, one of my favorite hobbies is that I love to travel. So these are some photos from my most recent trip to Japan and Thailand, and just a couple quick little videos. One of me battling a samurai up in Nikko, Japan, and another of my girlfriend's car getting swarmed by monkeys in Thailand. And the reason why I start the course off with this is because I know structural engineering is typically not the first thing that comes to mind when people think of their favorite, most fun course that they took at college. And structural engineering professors tend to be not the most fun people. I know because I have taken a lot of structural engineering courses. One of my goals for this course, a personal goal, so something that's not in the syllabus but that I'm keeping in mind, is that I want to try to break down some of those stereotypes that a lot of people have of structural engineers and structural engineering as a profession. Because obviously, personally, I find structural engineering fascinating. I find it very, very interesting. And hopefully I can convince you that structural engineering actually can be interesting to learn about. And the main reason why I find structural engineering so interesting is because I get to look at these massive monuments like this, like the Burj Khalifa and the Sagrada Familia, and I get to start to break down in my head how it actually functions. I've always been someone who likes to take things apart and look at how they work internally. And personally, I think that this is a curiosity that all humans have. I think everyone, to some degree, likes to look inside things and figure out how they work. So, with this course, I'm going to try to tap into some of that natural curiosity that you all have, and try to answer some of the basic questions of how these structures function so that you can start to understand them better. And then maybe one day you can start designing some massive cultural cornerstones like this. Because ultimately, good architecture does not happen without good structural engineering. But before I get too far ahead of myself, let's look at the course syllabus. And let's jump to the actual goals that I've listed in the course syllabus. And you can see that I've got 6 of them. At the end of this course, students will be able to, number 1, understand the relationship between the architect and the structural engineer. Number 2, discuss structural mechanics with a structural engineer in a conversational manner. Number 3, approach structural topics in the architectural registration exam with greater confidence. Number 4, prepare a preliminary structural layout for a given floor plan. Number 5, understand and follow structural code language found in the International Building Code. Number 6, use structural mechanics to push the creative design processes forward. And I think all of these goals are accomplished through curiosity. It all starts with a curiosity of structural engineering and how buildings get put together. If you remain curious about that, then you will accomplish all of these goals with ease. So, if your main goal is to learn and be curious about how buildings are put together, you will find that you will do well in this course very easily. However, if your goal is just to get through it, just to pass, and your only concern is that passing grade at the end, you may find yourself struggling. And that's because ultimately what I care about most is effort. I don't expect you to get everything correct 100% on the first try, but I do want to see effort put in to answer and try to figure out each problem on your own. So, be curious, ask questions. This is your time to learn and grow. So, why does the university think that it's so important for you to take this course? And why do I believe that good architecture needs good structural engineering? Well, if we think back to our art history, all buildings in the past were designed and built by a quote-unquote master builder. And then at some point, we started to build buildings that were just so complex and had so many parts and pieces, and there was so much liability involved that we had to break it up into different specialties. And you can see that even within engineers, there are more and more schisms that are taking place, more and more breakdown of roles. But ultimately, all of these people share the same responsibilities. They all share a common responsibility to the owner to turn over a product that is functional, that meets the standards of what the client expects. They also all have a responsibility to the public to turn over a project that promotes people's health and well-being and safety. They also share responsibilities to their peers and colleagues, as well as to the broader professions in which they serve. Over and over again with successful projects, you will hear the words collaborative and integrated. And the only way to be collaborative and integrated is to have mutual respect between parties. And finally, they all share a responsibility to our environment, to the earth as a whole. And of course, they all share different levels of legal responsibility, but that's not really what I'm talking about here. What I'm talking about is ethical responsibility. And these ethical responsibilities you will find in the AIA Code of Ethics. And hopefully, if you are seriously considering becoming an architect, you have already perused this document. But if not, we're going to be jumping into it a little bit more later when we start talking about roles and responsibilities. So for right now, let's continue this conversation. And as I said, Buildings have become incredibly complex over the years, and codes have gone from just a single small little book called the Uniform Building Code, and it's turned into these massive texts with reference standards that just go on and on and on. So it's definitely way too much for one person to know, and that's why we've had all of these schisms into different disciplines and different specialties. But ultimately, everyone that works on the project needs to know what each other is doing in order for the project to be successful. Nobody can work just in their own little silo and expect the project to turn out well. So, as I said previously, building design is a collaborative process, and collaboration cannot occur without understanding, mutual respect, curiosity about what the other person is doing and why. So, with that said, hopefully you are now all so excited to jump into some math with the next video. But even if you're not really excited by math, don't worry, that's only a very small portion of this course. You can still have curiosity for structural engineering and not really like math that much. So hopefully I don't lose too many of you with the next video. I promise we'll get through it. Just stay curious. Thanks.